Hey guys, welcome back to our YouTube channel and welcome to the series of blockchain and cryptocurrencies. Welcome to Module 3.2, Ethereum Virtual Machine and Solidity Programming. Today we are going to talk about Ethereum Virtual Machine and Solidity Programming. This module is designed for beginners and expert level audience who want to learn more about Ethereum and its programming language, Solidity. And we have Black Widow to guide us in this particular module. So without further ado, let's get started. So let's start with the basics. What is Ethereum Virtual Machine or EVM? EVM is a virtual machine that runs on the Ethereum blockchain. It's responsible for executing smart contracts and making sure they run correctly. Smart contracts are self-executing programs that run on the blockchain and allow for the creation of decentralized applications or dApps. Now let's talk about Solidity programming. Solidity is the programming language used to write smart contracts on the Ethereum blockchain. It's similar to JavaScript and has a syntax that's easy to learn. With Solidity, you can write code that's transparent, secure, and can be trusted by anyone who uses it. One of the key features of Solidity is its ability to implement complex logic in a decentralized environment. This allows for the creation of trustless applications that won't require intermediaries or central authorities. Solidity also supports inheritance, which allows developers to reuse code and save time and effort. When writing smart contracts in Solidity, it's essential to understand the gas mechanism. Gas is the internal currency used on the Ethereum blockchain to pay for the execution of smart contracts. It's used to prevent spamming and other types of malicious behavior on the network. The more complex your smart contract is, the more gas it will require, which means higher transaction fees. One of the challenges that developers face when writing smart contracts is the potential for bugs and vulnerabilities. It's essential to follow best practices when writing code to ensure that smart contracts are secure and efficient. This includes using libraries and frameworks that have been audited and tested, as well as conducting thorough testing and debugging. To build a dApp using Solidity, you need to have a good understanding of the development environments and tools. There are several popular development tools available, such as Remix, Truffle, and Grandshare, that allow you to write, test, and deploy smart contracts on the Ethereum blockchain. So how can you start learning Solidity and Ethereum Virtual Machine? There are several resources available, including online courses, tutorials, and community forums. You can also participate in hackathons and developer challenges to hone your skills and build real-world applications. In conclusion, Ethereum Virtual Machine and Solidity programming are essential components of the Ethereum blockchain. They allow for the creation of decentralized applications and smart contracts that are transparent, secure, and trustworthy. By learning Solidity and EVM, you can become a part of this exciting and rapidly growing field. So as we had an overview of EVM and Solidity programming, let's take a deep dive into our core module of top 15 questions for Ethereum Virtual Machine and Solidity programming. So here we go with question number 1. What is the Ethereum Virtual Machine? The EVM is the runtime environment for executing smart contracts on the Ethereum blockchain. It is a virtual machine that allows developers to write code in various programming languages and deploy it on the Ethereum network. Question number 2. What is Solidity and why is it used for Ethereum smart contracts? Solidity is a high-level programming language used for writing smart contracts on the Ethereum network. It is similar to other programming languages such as C++ and JavaScript and is designed specifically for the Ethereum platform. Question number 3. How is Solidity code compiled and deployed on the Ethereum network? Solidity code is compiled into bytecode, which can then be deployed on the Ethereum network using tools like Remix or Truffle. Question number 4. How does the EVM ensure the security and reliability of smart contracts on the Ethereum network? The EVM uses a consensus mechanism called proof of stake to ensure that all nodes on the network agree on the state of the blockchain. It also uses a deterministic execution model to ensure that smart contracts behave predictably. Question number 5. What are some of the key features of Solidity that make it ideal for writing smart contracts? Solidity includes features like inheritance, libraries, and events that make it easier for developers to write complex smart contracts. It also includes built-in security features like access control and exception handling. Question number 6. What are some of the common vulnerabilities that developers should be aware of when writing smart contracts in Solidity? Common vulnerabilities include retrancy attacks, integer overflow and underflow, and unprotected function calls. Developers can mitigate these vulnerabilities by following best practices like input validation and using safe math libraries. Question number 7. What is a token and how it can be created using Solidity? A token is a digital asset that represents a unit value on the blockchain. It can be created using Solidity by writing a smart contracts that adhere to the standards like ERC20 or ERC721. Question number 8. What are some of the scalability challenges facing the Ethereum network and how are they being addressed? Scalability challenges include high transaction fees and slow transaction processing times. They are being addressed through solutions like sharding, layer 2 scaling solutions, and the transaction to a proof of stake consensus mechanism. Question number 9. How does the Solidity compiler optimize bytecode to reduce gas costs? The Solidity compiler includes various optimization techniques like dead code elimination and bytecode simplification to reduce gas cost and improve smart contract efficiency. Question number 10. How do you handle exceptions in Solidity? Solidity provides the try-catch block to handle exceptions in the smart contracts. The try block includes the code that might throw an exception, and the catch block includes the code to handle the exception. There are 3 types of exceptions in Solidity: revert, require, and assert. Question number 11. What is a fallback function in Solidity? A fallback function is a function that executes when a contract receives Ether without any specific function call. It is a default function that executes when a contract receives a transaction that does not specify any function call. Question number 12. Can you explain the concept of inheritance in Solidity? Inheritance is a feature in Solidity that allows a smart contract to inherit the properties and methods of another contract. Inheritance enables code reuse and improves code maintainability. In Solidity, a smart contract can inherit one or more contracts using the keyword is. Question number 13. How do you optimize gas usage in Solidity? Solidity provides several ways to optimize gas usage, such as using data types that require less gas, minimizing the number of function calls, and reducing the number of storage writes. Additionally, developers can use tools such as Gas Profiler to analyze the gas usage of their smart contracts and identify areas for optimization. Question number 14. Can you explain how Solidity's memory and storage work and their differences? In Solidity, memory and storage are used to store data. Memory is a temporary data storage area that is used during the execution of a function, while storage is a persistent data storage area that is stored on the blockchain. The main difference between memory and storage is that memory is cheaper and faster to access, but it is not persistent, while storage is more expensive and slower to access, but it is persistent. Question number 15. Can you discuss the security risks associated with smart contracts and how Solidity addresses them? Smart contracts are vulnerable to several security risks, such as retrancy attacks, integer overflow, and malicious code injunctions. Solidity provides several security features to mitigate these risks, such as input validation, secure coding practices, and the use of cryptographic functions. Additionally, developers can use tools such as Mithril and Oyente to analyze the security of their smart contracts and identify potential vulnerabilities. It is crucial to implement strong security practices when writing smart contracts to ensure that they are resistant to attacks and protect the assets stored on the blockchain. So that's it from Module 3.2, Ethereum Virtual Machine and Solidity Programming. And we should thank Black Widow for guiding us in this particular module. So see you guys in the next one. Thank you.